Hi everyone, and welcome to this video lesson on the biological approach to gender, which is obviously the last of our approaches to explaining gender. This is the final piece of content now for your paper 1 exam. So let's get stuck in. Before we get going, you will need your booklets in front of you and open to page 20, and you'll also need the exam questions that I printed and gave out to you in lesson today. So just get yourself sorted, and as always, kind of highlighter pens for annotations, and maybe a scrap piece of paper as well might be handy. So once you've got all of that stuff sorted, let's go ahead and start considering what we're going to be talking about under this section. So when it comes to the biological explanation of gender, there are 3 different factors that we're going to consider. We're going to consider the role of genetics and how that plays an important role in the development of biological sex. Not necessarily gender identity in the first instance, but biological sex certainly. Neurochemistry, which again is more related to biological sex but can have an impact on later gender identity kind of issues, and then the role of evolution latterly. Okay, so they're the 3 things that we're going to talk about. Now, a lot of the stuff that we're going to mention, specifically like genetics and neurochemistry and also evolution to a certain extent, you're already familiar with, so I hope this content therefore isn't too difficult for you. So we're going to consider genetics first. So this is our first factor, and obviously I do have your booklet kind of screenshotted there for me at the moment. So what we're going to start by saying here with this particular factor is that the biological sex of a baby is determined at conception. Okay, an idea that you're already familiar with. You already know as well that we're born with 23 pairs of chromosomes, okay, 46 in total. And what we're saying here is it is the last pair of chromosomes, so the 23rd pair of chromosomes, that contains the genetic information regarding our biological sex, okay? So what we need to know here is, what are we getting from our mothers and our fathers that then determines our biological sex, okay? So we can state here that the ovum can only supply an X chromosome. All right, so the egg that you're getting from your mother can only supply an X chromosome. The sperm, however, can contribute either X or Y, and that's why we end up, okay, with different chromosomal structures for females and males. Because if a child has inherited the X chromosome from the ovum, from the mother, but they've then inherited another X chromosome from their father, okay, from the sperm, then that obviously would produce a biological female. If, however, there's a different situation whereby they've inherited the X chromosome obviously from their mother, because that's all they can get from their mother, but then the sperm has contributed a Y chromosome, then that child will go on to become a biological male, okay? So we're mentioning here the genetic components, all right, that make up biological males and biological females, but we're drawing on the idea of where that comes from. So what are we each getting from our mothers and our fathers, from the ova and from the testes of our parents, and that determines the genetic structure or the chromosomal structure, which then in turn obviously produces our biological sex, okay? So just to refresh, it's the last pair of chromosomes that contain our DNA instructions, and an ovum can only supply an X chromosome, so that's what we always get from our mother, but depending on whether or not you get an X from your father or a Y from your father will determine ultimately whether or not you go on to become male or female. Now, as we've just clarified that on the previous slide, let's go ahead and get our booklets filled in. So if the sperm contributes a Y chromosome, then the zygote, the egg, okay, will genetically become male. If the sperm, however, contributes an X chromosome, then that zygote will genetically become a female, all right? Now, there is something else which we've already taught you when I previously went through the biological explanations a long time ago now, which is a third kind of like genetic structure that activates the testes around about 8 weeks into conception, that then creates a biological male. Without it, you obviously would stay female. All embryos, all zygotes are female to begin with, unformed gonads. So do you remember what that gene is that actually activates the testes at 8 weeks old and causes that zygote to then become a biological male, i.e. development of the testes? Do you remember it? It is actually in your booklet, so hopefully some of you were recognising that. I would like you to go ahead now and kind of circle it or make it stand out, because if you're in an exam situation, you can not only talk about the XXXY structure and where they come from, you can also bring in the notion of the SRY gene, okay? So as we've just said on the previous slide, male and female embryos up to 8 weeks have external gonads, or genitalia as they're sometimes known, identical, okay? At 8 weeks, genetically, XY males start to produce androgens that then stimulate or activate the testes, okay? In XX females, that doesn't happen, thus you get the female genitalia developing, okay? So as I've just said, and please add this to your booklets, if you get an exam question on the genetic factors involved in gender, then you can initially talk about XX, XY and where they come from, and you can also talk about the SRY gene to expand your answer, and that's especially important on a 9-mark question, okay? Now, that is the basic idea of, you know, the role that genetics play in biological sex, but we can, however, take it further now. So we can show how powerful genes are in determining our biological sex by considering what we refer to as genetic mutations. And these genetic mutations are known to have a significant impact on an individual's biological sex and later then their gender identity. So the two disorders are as follows. You have Klinefelter's syndrome and you also have Turner's syndrome. So the first one that I would like you to take a look at now is Klinefelter's syndrome. You want to come out of this PowerPoint temporarily and hit the video link that's in the assignment labelled Klinefelter's. You would probably be better here taking some notes on a separate piece of paper so that you're not making a mess in your booklet. Take a moment to get all those notes down, and then once you're happy that you've got an overview of it, go ahead and fill in the space in your booklet, okay? So pause this video here, come out of the PowerPoint and go over now to that video link. Okay. So you should have been able to take some good notes there. All I've done at the moment is just kind of screenshot some of the most important aspects of that video clip. You just need to make sure, all right, obviously all the other stuff is really good as well, but you do need to ensure that it is clear in your notes from what you've just taken that this affects biological males, okay, and that they are in fact inheriting an extra X female chromosome, okay? So it does affect biological males and they are inheriting an extra X female chromosome. So biologically they are male, but they have additional female characteristics, all right, from having that extra X. Okay. Same as before, I now want you to break away from this video clip and return and take a look at the second video that I've set to you, which is on Turner syndrome. So if you'd like to do that for me now, go ahead and take your notes. Once you're happy, fill in the booklet. Again, I've just screenshotted the most important aspects that I think were apparent in that video clip. And if you'd just like to make it clear in your notes for me that this affects biological females now, and in this case, they're actually missing the X female chromosome. So with Klinefelter's syndrome, the biological male is inheriting an extra X, giving them some female characteristics or complications rather. With Turner syndrome, they are missing one of the X's. So they've got 45X rather than 46X, okay? All right. So what I would like you to do now for me, please, is just take a look at the statements that I've provided you with here. And I'd like you to decide which colour is Klinefelter's and which one is Turner syndrome. So just take a quick look at them, just as a very quick check. This is one of the tasks that we're going to do when we come back after Christmas. So which one is which there? Okay. Did you get it right? So Turner's would be the green and Klinefelter's would be the purple. All right. Well done if you got that right. Okay. Like I say, we're going to do this task after Christmas. All right. So well done there if you could just identify that. Now, what I'm going to ask you to do at this stage is get the 9-mark question in front of you, please, if possible. And I'd like you to have a go at filling in the D, the E and the A for the genetic portion of this scenario, okay? Remember, you can refer to XX, XY and SRY in the E portion, the elaborate portion, so that you've got enough to say. So again, if you just want to break away here, all right, and pop some notes in there, and then I will give you some ideas of maybe what you should have in that section as well. Okay, so pause this here and have a go at that for me. Okay, so now just compare your notes to what I've popped into the table at this point. So we've just got a very basic definition of what the genetic structure of biological male and biological female is, all right, and kind of where that comes from in the elaboration. And then the application is just stating what the genetic kind of structure would be of Sven. Okay, so it's nice and straightforward in terms of what you can include there. Obviously this stimulus doesn't really lend itself to talking about Klinefelter's or Turner's syndrome. I would imagine in the exam, that material would be a much shorter answer question. I don't think that they'd be able to ask you a 9-marker on that, so be prepared for kind of shorter answer questions there. Okay, so that's the end of part 1 on genetics. You might want to stop and just kind of read back over your notes and then go into the second part, which is on neurochemistry.